Excuse me. Hello, we're back with the um, public health data we introduced in the previous lecture. Today we will get more into the regression parts of analyzing this data and a lot of practical points. And it will be very tedious, but data analysis can be tedious, especially when you have many variables and especially when it's a problem that falls in biostatistics and problems that are discussed in the pharmaceutical industry. In comparison, if this was a problem involving text mining, and let's say the problem was we wanted to excuse me. Imagine we wanted to predict the rating of a Yelp review. So we have a data set of Yelp reviews and we have the corresponding rating, which I think is a number between 0 and 5 or 0 and 4, something like that. And we want to fit a model, learn a model that can, if you give it the text, it can predict the rating more or less. And that case, the number of predictors will be at least as many number of words we have, and so it will be a total different approach, and there will be many words, like tens of thousands probably, and we wouldn't go over them one by one, but we are not doing that. So therefore we have to go to look at every predictor and okay. So this is our code. We clean up the memory and the console, load some libraries, read the data, make all variables lowercase, remove the NAs. So actually, let's go back here. And sorry, should have closed it earlier. Okay. Not available. So one thing that at some point we should do is to see if there is a pattern here involved with the not availables, and if it falls into any of the categories, if there's a, in other words, if the predictors values for those observations which we are missing are significantly different. That's something we have to do, but for now we just remove them. So we filter them out. Sorry, and so we are left with this many observations. And what's the dimensionality? So we have 71 observations, 191 predictors, and many of them are categorical, so technically there are more than one predictor. Categoricals categorical variables are effectively as many. So one categorical variable with k categories is effectively equivalent to k minus 1 numerical predictors. And at the end of the day, even though we treat them as categorical, when it goes inside the program, they're all translated into numerical values and they're treated as numerical. So what I want to say is that effectively the number of predictors is larger than 191 because we have many categorical variables, as you remember before. Okay, we'll get to that later. Let's just skip this stuff, and what we need to do is we need to go one by one over all the predictors again, and then we have a list, and maybe we can, just by looking at them, removing them. Maybe there are some redundancies. Maybe there are a lot of missing values in some of the predictors. So this warrants one by one inspection of every predictor. Okay. So if you go down the list, we have ID, which we don't care. We have H1, ABC, which is a response. We have sex, which is gender. It's categorical, but it's two categories, so we don't need to code it as categorical. Then we have church, which has many categories, and yeah, and it has many categories, so we have to code it as explicitly as a categorical variable. And in order to do that, so here I'm going down the list, so as factor, right? Then we have church activities, and since we have 6 missing values, just for the sake of simplicity, I remove this, or other words, I don't choose it. Obviously, I can see whether these 6 missing values coincide with those 10 missing values of the responses, and if that's the case, then maybe we don't need to. But for the sake of simplicity, I just remove it. And on the other hand, church itself is, although these two questions are different, they point in the same direction. So, and given that we have only 71 observations, I don't think we'll lose much. So I will not use this. I will not use this. I will not use church activities month. I won't use it again because of all these missing values. And what I do, I keep a record just for my own sake and just for the sake of a record to explain later if somebody asks me. And I create a list of predictors including NAs, and I just write them down here so I know. And sometimes if there's only one missing value, I still remove it, but ideally you would look at that one missing value and see whether that coincides with one of these 10 missing values. So one missing value we might be able to deal with it, and if it coincides with any of these, then we can keep it. But for now, for simplicity, we already have 191 predictors, so I will just remove any missing values first run. And as I go down the predictors, I also write down if they're missing a lot or not. So one missing values versus missing a lot. So if I wanted to check this list, I would go back to this one. And these ones miss only one. So anyway, you go down the list and you won't include any variable which has a missing value. Okay, and you keep a record for yourself. So later when you want to revise, you at least know what happened to those predictors. Okay. Then we have religion. And let's see if I use religion as I go down the list. So I don't use religion, and see why I'm not using religion. Okay, because there is some sort of imbalance. So again, at this moment, because I have 191 predictors, I'm removing anything that has can be slightly problematic. And slightly problematic means either they have missing values or there's a significant imbalance in the categories. And what I mean here is that 54 say religion is very important, and 4 say not at all important. Okay, and we have 71 observations. So 50, I mean, we don't know the missing values, but this seems very imbalanced, and essentially it's saying most of the people in this group are religious. So, and then there are a couple that, there are a few that are not. And whenever there is a categorical variable which is more or less constant for all the, for most of the observations in that sample, at least as a first layer analysis, this is a process, as a first step in the process, especially when we have many variables. I mean, later we can come back and look at this, have a closer look, but it's okay to remove it, okay? And then we have year born and age, and these two are saying the same thing. So I just use age, and then we have moving, how old were you, and let's see what I do with moving. Moving. Oh yeah, almost all are 1. So if you let's see the religion first of all. So most of them are 4. There are a few 1s. So anyway, this is something we can later add and see what the effect is. But for now, let's ignore it. The moving, all of them are 1 except for 1, 2. So it's again, there's no information here. When all of the observations in the same in the data set have the same and their predictor has the same value, then that predictor is not informative. So again, this falls in the category of imbalance. I remove this. Then we have years residency, and that is informative because, I mean, it has a mean of 20 years plus minus 10 years. There's some variability, so we keep it. It's a numerical. Then we have the moving age. How old were you when you first came to the US? And again, there is some mean and there's some variability. And that's why I just keep them here. Years in the USA. Okay, let's see why I'm not keeping moving age. That's interesting. Maybe because of this one missing value. Did I do that? Years. Moving. Yeah, we talked about that. So let's see. Moving age. Yeah, because only of this one. Maybe we can just. Well, it's not. Now we know it's not the one which has a missing response. So we can impute it, which has its own problems, and it's a different story. But for now, let's ignore it because of the missing value. Okay. How many parents were born outside of the US? So all 81 say 2 parents. So this is meaningless. I mean, it's not meaningless. It is useless for what we want to do. So the next thing we will keep is marine acculturation short scale. What is that? I don't know. I have to ask. Okay, so this is something domain specific. I should get to know this, and whoever is analyzing the data should at least know more or less what it means. I did some research, and anyway, since 87 has been cited this many times. So it's something that has been used in the literature, and I found this paper for the first time. Oh, that's why it's called marine. So it's a measure for acculturation, and one can easily look at this paper. There's not much math, and see why this acculturation scale makes sense. And me, as somebody who's looking at this data, should read this paper just to make sure I understand more or less what it is. But it's mostly domain specific. So when it is accepted in the literature, in their literature, I accept it. But one shouldn't be completely blind to the predictors. Okay, so we keep it here. The mean is 18 plus minus 16, so there's some variability. That's good. Education. Excuse me. Education, what is your highest level of education completed? And okay, so you see the categories 25, 22, 2. So the numbers here are so small then that maybe it is more reasonable to collapse them into another categorical variable where you have a more balanced number of observations within each category. So 7th to 11th grade, these two are collapsed, so we have 47 here, and we have 19, then we have 2, and then we have 13. So I would actually collapse these two together too, because 2 in this category is not very helpful. And okay, so I would create a new one, new variable out of this. So let's see. What happened to education? Okay, so I'm not using this. I'm using education cat, and let's see what that is. I did that before. Okay. Yes, categorized. Below 11th grade, high school graduate, or GED, some college but no degree. And let's see, it says no degree. Let's see. Education 10. Education 10. So it's any college plus some college, but no degree. Anyway, so if you collapse these two categories, we get edu cat 10, or which one was it? It's confusing. Education 10. Okay. And then, no. Sorry, education cat. So this is what happens. You have many categorical variables which are saying more or less the same thing, but they're collapsed in different ways. But here, anyway, we're using this one. I will use this one because it's more balanced in the categories we have, and that's what I have written here. And so it will show itself up somewhere here. Okay, here we have it. But it's going down the list. We have marital status. We have these 6 categories. Okay, and you see we have one observation here: widowed, separated, divorced, and we have one observation here. So let's look at this: the marital status. Okay, so I would because of this imbalance, I would just remove it, or I would collapse these 3: divorced, separated, widowed. I would have a conversation essentially with my colleague about this. But for now, let's just remove it. And since we are removing it, I just want to put it here where I am removing it. Okay, I'm removing it here. One widowed, and I would write that. One widowed. So when I look at this, I see, okay, the problem is there's a one category with widowed and there is only one observation. So maybe it's not a big deal, but at the moment I don't want to deal with it for my first round of analysis. So I ignore it here, and then we have general health. Poor or fair, good or very good. Okay, so this is also categorical, but it's binary, so we don't need to code it as numeric, as categorical, knowing that it will always be comparison to poor or fair, general, rude, health, and then we have IPAC. What is IPAC? It's a level. Again, we can look at it, what it is. Okay, so it is a international physical activity questionnaire. So so it's a measure for physical activity, and then you can look at this document to, or similar documents, just to look at it, see how it is calculated. But that's not what we are focused on, but this is something that will be part of this analysis, just to understand, at least at a high level, what IPAC means. Okay. Meal planning. Are you the person who does most of the planning or preparing of meals? It's not very imbalanced, so we keep it. Food shopping the same way. Supermarket has 16 missing, so we'll just ignore it. Small grocery store, 77 missing, we ignore it. Let's just go back here. Meal planning, food shopping are included. Okay, so I think there are a few items here that I missed putting there. So let's go. So supermarket. Let's see. Yes. So we have supermarket. Then we have small grocery store. Remember, food shopping we included. Yes. We have the okay. Convenience store. Yes. Big box store, wholesale. All these are missing. Other kind of store missing. And then we have neighborhood. 0 missing. And neighborhood, there are a couple of neighborhood categorical variables which are important for this study. There's a large selection of fresh fruits and vegetables in my neighborhood. It's very imbalanced, because almost 70 of them agree. So so I ignore this. Here too, neighborhood 2, neighborhood 3 is also very imbalanced. Neighborhood 4 is not, except there's only one here with a strongly agree. So I would just collapse these two and have strongly agree. But again, it's a lot. It's 50. So I don't know. Neighborhood 1 to 4. Let's see. One, two, three, and then I think I will keep neighborhood 4, 5, 6. Let's see why. Yes, because neighborhood 3, the imbalance is. Maybe I should keep all of them. I don't know. It's a good question. Let's just keep all of them. Who knows? They're all related, and the imbalance is. Let's see, we have neighborhood 6. So we have 1 to 6 and 6 neighborhood related questions about crime rate, about walks during the day, and a lot of them are related. Fast food, high quality fresh fruit. So let's just keep all of them for now. Okay, so we go back here. I remove them from here. I add them here. I take them to the next line and I add as factor because they're categorical. Six. Okay. We have a food security scale. It is categorical, but it's also there's an order involved. So there's that, and then we have food security dichotomous, because these two are more or less saying the same thing. And this one has two categories, which is a little bit more balanced, and yes and no. I would go with this one, meaning that, oh, but I use both. And let's say, okay, let's say we remove this because food security is a three category version of here. Okay, so let's just remove this. Then we have smoking. Wait, 79, not at all. So this seems to be an irrelevant, not informative predictor. So smoking comes here. I'm just trying to keep it in the same order. Number of cigarettes, 79 missing. Alcohol, 35 said never. Half. So I don't know. It's a numerical. And let's look at it. It says what one non-missing value is not labeled. So the alcohol, what is that? No, that's okay. So let's keep it. Let's see what we get. And it's not categorical. So where were we? After neighborhood, we went to food security data. Number of drinks. Missing 35, so number of drinks is not here on the list. Just add it. full-time working, 50 missing. Part-time, 60 missing. Self-employed, 80 missing. So let's just add those here. Time, part-time, self-employed, unemployed, retired, disabled, student, what else? Homemaker. Let me get to SNAP, which we include because there's no missing values, and there's some sort of, it's a yes and no, it's categorical, we treat it as numerical because it's binary. Final income is a categorical, and again we have income. So income is a less detailed version of family income, and because there are so little observation in these categories, maybe income is a better way of using this information. So income we have here, family income, should be here, isn't here, or maybe it's because of redundancy. So I say is captured by income. Sending money. There's a yes and no, and there's a refuse. There's two observations there. It seems problematic. I have to speak. Anyway, whatever list I create at the end, I have to speak to my colleague and say it's okay. Is it okay to remove these, because 2 in this category is problematic. So balance, sending money. Let's see, sending money I don't use, right? And then we go to political views. We have own home, 78 say, so imbalance. Group neighborhood. Are there any groups in this neighborhood, such as block clubs or community? And yes, no, don't know. Three categories. Groups, neighborhood. So I arbitrarily remove it, and arbitrarily because don't know, at least if it was yes and no. But anyway, this is something I have to have a conversation. So for now, let's just ignore it. Groups, neighborhood, involved. So when I say arbitrarily, I should say to be discussed. We need to discuss these. Then let's see. What was this? Group neighborhoods involved is removed because of they're missing. Group neighborhood involved is removed because they're missing, not because it's arbitrary. Neighborhood because they're missing values. US citizen, 74 in one category, so not very useful. Other citizen, it might be interesting to see whether that has an effect, but when you have 6 observations in one category, it's really, and so many predictors, I don't think you can capture that effect with 6 observations. The same about other citizenship, so US citizen and other citizenship will be removed because there's imbalance. So we were here, just add them. Then we have other citizenship. We remove. Then we have moving one. Did you move from the from your country of origin because your family wanted to or yeah, we have to look at this question, but for now there's one missing. There's don't know, refuse, had to, wanted to. So again, this is one thing I have to have a conversation. It seems arbitrary, but let's just put this as missing. Then we have moving one, and we have moving two. My only problem is the balance. There's no balance, so most of them say wanted to or had to, and how do you draw the line, more or less? So moving one and two goes into balance, right? Oh, I have it here. Okay. Good, I already put it there. So then we go into political views, and we have 7 categories. Let's see if we are going to use it. Yes, so we need to make it as factor. Acculturative stress. Do you feel guilty for leaving family and friends? Yes and no. Pretty balanced. Acculturative stress 2. You have the respect you had in your own country. Yes and no. Balance. Stress 3. More or less balance. Nothing missing. So we go from stress 1 to stress 8, and all of them are more or less balanced, and you can look at the questions. I don't want to hold you up on that, but and then there's a summary of it, which is numerical, I think. Is it numerical? Yeah, it is numerical, value 1 to 8, and so let's look at them. Acculturative stress from 1 we have 1 to 8, and then we have the sum. And then we have BMI, we have K6, scale, we have A1C. So what happened to A1C? So these two are more or less saying the same thing, and not exactly actually. Let's keep A1C actually. Let's see what we get. The problem is that here's the thing. A1C is a categorical version of the response. So obviously, if you regress the response, which is HB, so we have the HB1AC, and then we have the A1C, and there essentially this is a categorized version of this one, and so if you plot one versus the other one, we can easily see that any HB1AC that's less than this threshold is categorized as A1C0, and then we have in this interval we have 1, and then we have 2. So there's obviously a relationship. It's as if we are regressing one thing against itself. So that's why I ignored it. Okay, so let's just let's just remove it. That's why it's good to take these notes, so later when you come and look at your code, you know why you did what you did. So just put this, no, A1C. So we were here. A1C is a categorized version of HB1AC. So let's look at uncontrolled. Again, uncontrolled is a truncated version of HB1AC. Somewhere here there's a truncation going on, so we don't take this. Okay, let's see what else do we have. Let's see, no. Okay, so no has a non-trivial one-to-one. It doesn't have any one-to-one relationship. In other words, it doesn't seem that no is a summary of HB1AC. Specifically, it's one of these 6 categories. So we have 0, 1. Essentially, we're just separating whether they're told by MD or not. Oh, I see. So this is about whether they know or not, and now I see what's happening here. So if we overlap these two, and these two, and these two, then we get the A1C. So okay, so it is A1C plus, so it's a truncated version of the HB1AC plus this extra information whether they also told by the doctor whether they have diabetes, I think. This is interesting. Um, okay, so for now I ignore it. This is something I have to look into. Closer look and see what this is. So it's to be discussed. Let's just say to be discussed category. Then we have no. Okay. I think no was here. Then we have insurance. Let's see what do we do with insurance. We ignore it. Why do we do that? Oh, okay. Let's see. We have insurance. And we have insurance, yes. And so we use, instead of insurance, we use insurance, yes. So we don't really distinguish between Medicaid and Medicare and private. Maybe we should do it. So let's actually do that. So we insurance. Okay. So let's just remove this. And we add here insurance as factor. And we have age, immigrant, two categories. And there's nothing missing, but let's see. We have age. Okay. Doesn't have anything to do with each other. Let's see. What is age? Okay, we have age. don't have age immigrant. That's interesting. It's migrant, sorry. Okay, we have it here. So age migrant. Okay, why it's there? Let's see, where's BMI? K6. Oh, okay. So we had these. They had K6. Okay, we have. It's all after K6. Okay, that's why we are missing this. Age migrant. So, okay, this should go. Insurance. Yes. Oh, okay. So it's insurance. Let's see. We wanted to use. Just remove this. We want to use insurance. Then we want to use age migrant. Then where's KCal? Okay, KCal hasn't come yet. So we have food security categories. It's these categories: marginal, low, very low, and okay, so we are ignoring this because it's 3 category version of food security dichotomous. Maybe we can just, I mean, there's no reason not to use it, but except that these two might be very similar. So yeah, so let's just use food security. I would try, if I wanted to do this analysis completely, I would try it with and without, with 3 categories and 2 categories. So for now, we just have age immigrant, so we ignore that. Then the usernames, forget about it. Kilocalorie, then we have HEI vegetables. Mean is this. This is the standard deviation, no missing values. So all these HEI measures of the intake of different different foods, I guess, or different portions of that make up the daily intake of food. And whole fruit, whole grain, uh, dairy, protein, seafood, plant protein, fatty acid, sodium, refined grain, saturated fat, added sugar, and there's a total score. So none of them had any missing values, so we use all of them, and they are important. So they just start here, then they go this. Okay. Then we have density versus sparseness of the social networks. I don't really want to go into this as a lot of details, but essentially we look at the alter network, meaning the individuals that this individual has interactions on a daily, weekly basis, and how much they influence the habits of that person. These are all numerical. Mean 51, standard deviation 24. Your percentiles, nothing is missing. So density, transitivity, um, prop female, prop under age 18. There's one missing, so let's just look at this for a second. So we have these don't belong here, so just take them down because we are somewhere else. Okay, density, transitivity, take this up. Okay, was one, okay, prop age under 18. See. Okay, so nothing is missing, which means that that one missing one is one of the 10 that are also missing the B1AC. So we use it actually. Let's use it. So we use prop age under 18. Okay. These are all, yeah, these are all numerical ones actually. Okay, so we go from 38 to, so we have the okay, great, nothing missing here. Then we have the prop 35 to 54. These are proportions of the network that are in these age groups. Okay, so now I'm going to remove these prop ones because I had put them here as missing values. Okay. So after these we have prop all family, prop close family. Nothing is missing, a mean standard deviation, so it does a meaningful distribution. Let's see. Prop all family, prop close family, prop friend, and then we have relative diversity. Okay, so these have all very specific meanings, and it's just beyond the scope of this class. But again, this is part of the analysis. You have to read them and understand what they mean. Prop BC meg. 5 are missing. So let's check this. Okay, so we have a lot of missing ones here, so we ignore it, and that's why it's probably not there, but should be here in this list of missing one. Prop PC Mic. There we go. So nothing is missing. Great. As expected, because it wasn't there. Oh, we have it already here. Then prop English speaking, prop live out of the country. In another country, same household, um, same household or neighborhood. Okay, prop same household or neighborhood. Neighborhood, and then we have, we can just do it this way. Prop okay. We're born in Mexico and currently live in another country. Then we are here. Okay. So now I'm just going down the list of the data dictionary. These are all proportional, and you can just sometimes these sentences are pretty clear, sometimes they're not. But I'm just going down one by one just to refresh my memory what they are and make sure that I have included everything and excluded everything that I need to exclude based on missing values or the categorical variables being imbalanced or whether there's some redundancy in representation. And we have seen all three examples. So I'm just going down the list, okay? And that's why I don't say much. I just make sure that this is, okay. I make sure that this is here. And there's no missing value. Okay. Okay, now we're moving to different kinds of network that attends church. Network constraint ego positions. I don't remember what this is. Age category. Well, we have age, therefore we ignore age category. Where is it? Okay. Age. Working, yes, no. Yes, no. We have that. Okay, then we have the income, and we have the incomes already. So income below 30, and income below 30 is captured by what is SNAP? Yes. Receive SNAP benefits. We have that already. We had SNAP. Moving age category of so essentially it's if it's below 18 or not, and I don't remember what we did with age, moving age category. Let's see. Ah, yeah, moving age. So let's see. This is category, right? Yeah, so we have this. That's why we are ignoring it. Religious vary. We have no yes. 77 in one category, so we just ignore that. Yeah, we have it here. Insurance, yes. Yes. Is captured by insurance. Okay. Lose weight. Yes. What did I do with that? Okay, let's just ignore that. Let's just yeah, I removed that, but let's just put it back. We have education category. So you see it comes back. We had already education somewhere, and well, you have it here anyway. We're using it. gender, this is gender. It's the same as sex. E sex, D female. So that's why it's important to go over the data. There are some methods that we will see, or maybe, uh, hopefully, we get to talk about them. Specifically, something like ElasticNet with Capture, which is able to work with um, scenarios where you have a lot of predictors, and some of them are highly correlated, or could be even the same, like here, and they don't create any problems. Okay, but here we're removing them, and that's why we remove female, because female is captured by sex. But where is it? Okay, we haven't put it there. Female is captured. Okay. And then we have diabetes. Yes. 76 said yes. I don't know. Again, it's very highly without any information. And all the individuals have the same value or category, then that feature, that characteristic is not informative. Okay, so diabetes, yes. I don't know what's in redundancy. It should be here. Okay, we have it. Diabetes, yes, too. And then we have the education categories. All of them are redundant, or because we chose the other one. And then we have food security 1 as high. Again, these are all redundant because they were captured. And we have food insecurity, which is binary. So I don't know if this is better to use um, or the it's essentially the same as food insecurity dichotomous. Food security. Then we have it's exactly the same thing. No, it's not. Hmm. Let's look at this again. This is actually our last one. Food insecurity is marginal low or very low, yes or no, and then we have uh, food insecurity happened, or maybe security. Dichotomous. Yes, no. 30 yes, 51 no. 35 no. Okay, so this is something, again, one should look into, see what's going on, which one is more. Oh, this is marginal. This is very low. Okay, got it. So yeah, we have to make a decision which one to pick, and this is marginal or low or very low. I would, and then we have dichotomous. Let's go just with dichotomous, and then something that we can make a decision later. To be discussed. Uh, 1, 2, 3, okay, and then which one do we use? We use the dichotomous version, I guess. Oh, here it is. Okay, so we use this one. Are ignored. So this is something just to is it this one? Which one is it? Okay. Rate expectation. We use it. Yeah, I can search, but anyway, this is enough. So you got the idea what we're doing. I don't want to spend too much time. So we got to the end, 52 pages, but this is the process, and this is how you get to create an initial list. So just of the terms, okay. Now we have this. Oh, let me just make sure education. Let me just write this down too. That education is used and are ignored. Okay. All right. Start. What is here unexpected? I don't know. Oh, okay, we need this. So we just try to, I just try to do a regression fit, and 98. We have 98. Hmm. Okay, so these are all the variables, including the response, but since one term is always the intercept, so it's okay. But it's essentially one, it's minus one, if I want to be precise. And let's look at the LM fit. Summary fit NAs and some estimates. 56 coefficients are undefined because of singularities. Why? Why is it 56? Because so P is 97. Okay, but it's not. It's more than 97 because we're dealing with categorical variables. Not these ones, but political views, for example. We have 7 categories, and all these coefficients are in comparison to category 1. Okay, so we have more than 97 features here, and we have 71 observations. So we have more unknowns than knowns, and essentially what that means is that the X matrix, so X transpose X is not invertible. What it means is that the columns of X are linearly dependent. And let's just look at this X matrix. Now we can look at the dimensions, and yes, you see now that we have 71 observations, 127 rows, and this model matrix is just X. And this model matrix turns categorical variables into multiple columns. So X row 1 first 10. So the first column is intercept. Then we have sex. Then we have the third column is church as a categorical, category 2, category 3, category 4, 5, 6, 7, and this is interesting because when the first row of X, the category for church is not 2, 3, 4, 5, 6, or 7. What can it be? It's 1. And we can see that by looking church and looking at the first observation. You see it's 1. It's 5 here. It's 5. So, and then you see age 20 years in the residence in the US. So anyway, here we have our friend, the X matrix. And yes, so, and okay, we have that. We can also have the H1AC. Okay, we have Y, and we have our X, whatever, summary. X, okay. Now the next thing we can do with this is theta hat, which is what? It is X transpose X, right? The inverse of this, and we do solve to do that. Then we have talked about solve before. So you have A, X is B. You right. You have A. You want B. You have B. You have A and B. You want to find X. You just write solve A and B. Now for us, A is X transpose X, and B is X transpose Y. Okay. And it's in the, what package is it? Matrix. So just make sure, have I loaded matrix? No, so just put it there. Library, matrix. Okay, so I don't have a, just have matrix. Okay, so maybe I need to install it. Okay, well, wait a second. Let's just save this first. And now, what do I want to do? Install a package, matrix, install it, and yes, I'm okay. So let's just pause this. Okay, so I had to restart this. Let's do this again. Oh, problem is path. Typical problem, easily resolved. Let's remove this. This is not P. It's misleading. I don't know, maybe I don't need it. You see, it says error. System is computationally singular. Meaning, this means that the columns of X just write this down there. This is going to say that the columns of X are linearly dependent. Okay. And the dimensionality of X is okay. So n is equal to this. P is equal to this. And here we have more columns than rows. Just a reminder of where this is all related to. Remember when we were doing least squares, this was the equation which we were trying to solve. We wanted to find a theta, which is a vector, so that the residual sum of squares is maximized, and we took the gradient, and then we had to solve this equation. So essentially we had to find a beta that satisfies this equation. So this beta here is, or well, beside there, never mind. And sometimes this equation has only one unique solution, sometimes it has no solution, sometimes it has infinitely many solutions. And it has a unique solution when n is greater than p, or greater equal than p. It can also be equal. And x is full rank, meaning that the columns of x are linearly independent. In other words, when n is greater than p, then x being full rank means that essentially this when doesn't need to be here, but x is full rank means that the columns are linearly independent, and if they're linearly independent, this matrix is invertible. There are a couple of linear algebra steps from this statement to this statement, which I skipped, but I just want you to focus on the concept of linear independence and whether this is a tall matrix or is a wide matrix. If it's a tall matrix and the columns are linearly independent, then we can just take the invert and inverse and find the least squares solution, which is what happens in R. But here we can't do it because they are linearly dependent. Okay, so here is again a quick review. Linear independence. What we mean by it is that imagine we have a collection of p-dimensional vectors x1 to xn. Okay, so just when you read this, you will realize that what is p here is n for us. It doesn't matter. What matters is that if you have a collection of vectors, they are linearly independent. When we say they are linearly independent, it means that there is no way that we can combine them and add them up together with any kind of weights so that they add up to zero. Or, in other words, that any of them can be represented by the rest. So there's some redundancy. When we have linear dependence, then there is redundancy in what they say. But when there's linear independence, then there is no redundancy, and each of them is pointing in a different direction, and we cannot combine any subset of them to tell the same story that the other predictor is saying. Okay. Now this is important. So what it's saying is that in a p-dimensional space, n vectors are linearly independent only when n is less than equal than p. So in other words, any collection of p plus 1 or more p-dimensional vectors, this collection is linearly dependent. And if you want to read more about this, or if you want to go deeper into it, this is the introduction to applied linear algebra book. The PDF is online. You go to page 94. But when we want to apply this to our problem, what is the dimensionality of our vectors? Okay, it's P for us is n. Okay, because n is the number of rows, and each column is n dimensional. So we are speaking about 71 dimensional vectors. So P is 71. So if the 71 dimensional vectors x1 to xn, how many of them do we have? Well, as many columns as we have, and it's 127. Okay, so if the 71 dimensional vectors x1 to x200, sorry, to x71 are linearly independent, then sorry, just got confusing again. 127, 7. Okay. P is 71 here for us in this statement, and we have 127 vectors are linearly independent, then 127 must be less than 71, which it isn't. So they are linearly dependent. Okay. So I mean, it sounds complicated, but it's not. It's actually it's not. Okay. This is okay. So this is the last thing I wanted to say. So if the columns of X are linearly dependent, then we have some non-zero vector that we can apply X to it, so or calculate XV and get 0. So the columns of X are linearly independent if XV only happens when V is 0. But if they are dependent, there is some non-zero V that satisfies this equation. Okay. And then I see. And then we have overdetermined, underdetermined systems. These are all things that we talked at the beginning of the semester. I'm just quickly going over them. And if you want to, at a slower pace, you have to go, I guess, maybe even to the first or second lecture. But what you're having here is this. We have a linear equation, and it is underdetermined. There are more unknowns than equations. We have 127 coefficients that we want to estimate, plus, 127, yes, and we have 71 observations. Okay, so that's a problem. Now, let's just change this X. Let's say we just take the first 10 columns. All the rows, column 1 to 10. And then now we don't have any problem because, because we can just, there are 10 unknowns and we have 71 observations and we get some estimates and so now we are suddenly in this overdetermined where m is greater than n. No, sorry. Okay, this is anyway. Focus on this sentence. Overdetermined. There are more equations than variables, and equations here mean for us observations, and unknowns mean coefficients. Okay. Now, the next thing we want to do is we want to apply the forward-backward method to work with the full matrix and do some sort of variable selection. That's the next thing we want to do. But this was just more about data cleaning, essentially, most of this. Okay?